Okay, now that we have the site added to the node hierarchy on the left, we now have to add the logger itself to the Neon server. So this is where we configure the NRT. So we do add logger, and we have to fill in some parameters. So we name the NRT. You can have multiple NRTs per site in the node hierarchy. So people choose to name it by serial number or function, or if you have a particular cell node, which is a oil well, for example, you might have 3 pumps there with NRTs on them, so you name them accordingly. Now, this is crucial. To identify an NRT to the server, there's 2 pieces of information. The first one is the NRT serial number itself. So that's written on the label on the front of the NRT. There's a small window panel that tells you the NRT type and the serial number. So we just copy that off the NRT. Sim reference is a freeform text field where you just put reference information. People usually use it to record the SIM card number, so that when they get their bill from their from Telstra or whoever, they can identify this particular NRT's data usage that month. We won't bother for the moment. The comms frequency determines how often the NRT sends the data to the server. That can be as quick or as slow as you wish. For a typical site it might be 60 minutes, but for real-time monitoring it will be a much shorter interval, like 5 or 10 minutes. If it's a rainfall site it might only be once a day. Comms offset you don't have to worry about. Neon will default that to 0 for you. That determines how many minutes away from the hour in this particular case the NRT will communicate. So this one we've set to hourly comms, 60 minutes, but if we don't want it to actually send the data on the hour, we would enter so many minutes past the hour in this field here. Retry attempts are automatically configured by the Neon server, so we just select the the NRT type here. We're going to use a 2013F there, and we have a standard memory model, small memory model NRT, so just the standard 2013F. External power has a few pre-configured options: 6 volt, 9 volt, 10.8 volt, 12 volt. That determines at what voltage the NRT switches over from external power to internal battery operation. So if you're running the NRT in the field of external power and it's a 12 volt lead acid, for example, you would typically set that to 12 volts because a lead acid battery its actual voltage is 13 point something when it's fully charged. So by the time it drops to 12 volts, the external power is going flat, and then it would swap over to internal power. So we also need a Neon scheme, which is the program that the NRT runs to collect the data. You should have already created that, or Unidata can also create that for you if you wish. We're just going to use a simple battery monitoring scheme here. Schemes are saved on your C drive under Starlog v4 schemes directory, and we're after the schemes that you upload to the Neon server are always scheme name.neon. So we'll just search for those. We only have a few schemes here, and we're going to use the battery scheme. So double click to select it. It appears under scheme files on the Neon server, and we push upload and save. Neon has now created the logger on the Neon server, ready to receive the data from the NRT in the field. Now, rather than do all this once the NRT is in the field, it's always a good idea to test the NRT on your desk before you take it to the field. It's a lot easier to solve problems in the office than it is in the field when it's hot or raining or whatever. So in preparation for configuring the NRT, we now have a node which is a site to contain the logger. We've created the logger on the NRT site. Now we have to remember this key field here, which is called the NRT ID or XRT ID, and we have to configure that number into the NRT using Starlog v4. So the serial number and the NRT ID identify an NRT in the field to the Neon server. So we're going to take that number, 3276 in this particular case, and we're now going to program that into the NRT using Starlog v4.